On Friday, September 28, 2018, on the island of Sulawesi, Indonesia, an earthquake followed by a devastating tsunami destroyed the Bay of Palu. Within minutes, 4,000 people lost their lives and 79,000 others had to be evacuated. How could such a tragedy happen again after the 2004 tsunami that already devastated Indonesia? Two tsunami specialists, Professor Kostas Sinolakis of the University of Southern California and Professor Herman Fritz of the Georgia Institute of Technology, were sent by UNESCO and the Indonesian authorities to investigate the causes of the tragedy.
Quite impressive to see the devastation. We're now 3 weeks after the event. And then here we can kind of see why it's important to come up as quickly as possible, or at least once the emergency is over, because a lot of bulldozing in this area already, so a lot of evidence is already lost.
For those who know how to look, these fields of ruins hold clues of the wave passage. But time is running out. The monsoon will soon wash away the remaining traces.
Working as a tsunami scientist is very much like being a detective on a crime scene. There is multiple murders that have taken place. You really have to piece, like in a puzzle, the sequence of events. Did the tsunami hit first and this made the houses collapse, or were they collapsed because of the earthquake and the tsunami finished them off? What were the people doing? Why is it that some people died and some people did not?
Both investigators want to understand how the disaster unfolded. Their goal, to trace the tsunami back to the original event that triggered the wave. In the small fishing town of Wani, Kostas Sinolakis goes to meet the survivors. Abdulatif miraculously survived. When the wave came, he was on his boat 100 meters from the shore.
Hey! Sir, get off the boat! Get off the boat! At the time of the first wave, when there was the big tremor, I went out on the deck of the boat.
Did you feel the tremors on the boat?
Yes, the boat shook because the water had gone down and the boat was grounded.
What did he do at the time? He stayed with the boat?
Did you stay on the boat?
In front, over there, I was holding onto the mast.
Oh, okay.
And then I saw the wave breaking in the distance. It was very fast. In no time at all, it was next to the boat, pushing us.
About how high was it?
I had time to see my house. The top of it was almost at the same height as the boat.
Where is your house?
Over there. The wave was about 5 to 6 meters high, the height of my house.
For Kostas Sinolakis, this tsunami is an enigma. How is it possible for a 5-meter high wave to crash through here when a bay is usually protected from tsunamis? "20 kilometers south of Wani, Herman Fritz is investigating in the town of Palu, where thousands of people lost their lives. With the help of 2 Indonesian scientists, Herman Fritz goes to the parking lot of the shopping center overlooking the bay. In order to understand the dynamics of the wave, he relies on another kind of witness: mobile phone videos.
This is the exact spot that we saw on the video. Here you can see the billboard.
Yes. Tsunami wave coming, people running away.
People running away. Yeah, oh.
And that's the second wave.
That's the second
wave. Okay, that's the highest one. So now we can basically see how high the water is, almost on top of the billboard.
Here, the wave reached over 4 meters in height.
Yeah, so 1.6 here. Okay, 4 up there. Okay.
Ini ya Allah, tsunami ya Allah. Ya Allah, tsunami ya Allah.
To trace the source of the tsunami, Hermann Fritz needs to establish a model of the devastating wave, determine its height at different points in the city, and measure how far it spread inland.
I'm going to try to do some detailed surveying here, so we're going to try to get a full 3D scan. And the purpose of that is so we get a 3D space. Basically, the LiDAR scans all the point cloud, and we can see how the waves go through it. So can we measure how high the wave is at every given instance, and how fast the wave is moving across through the houses, washing away the houses, and across the street.
Hermann Fritz tracks the wave. After submerging the parking lot, the water penetrated deep into the city. In this mosque, which is only 100 meters from the shore, clues bear witness to its power.
This one's broken. We have this grill here, and we see this rafted debris inside. So we know that the tsunami was at least to this height of this rack. And then up here, we see the actual primary tsunami line, which is this one right here. And we can also see it in the window. If you look at the blue sky, we actually see a mud line going through there. And then we look at that over here, we also see the mud line coming around, coming around, coming around. So the tsunami is coming pretty much at the height of my head through this mosque. And that's also a very difficult height already, because usually when the water is to this height, you cannot stand anymore. You will be thrown to the ground by the water, so it can be difficult to survive.
After 3 days of fieldwork, the two American researchers and their Indonesian colleagues are finally able to produce a first simulation of the tsunami that submerged the Bay of Palu. According to their observations, the most powerful waves spread more than 300 meters inland. But for Kostas Tsunalakis and Hermann Fritz, the investigation has only just begun. They now have to identify the event that triggered this murderous wave and determine how it could have swept into the bay. Tsu, the port; Nami, the waves. The waves that destroy the port. This word, now universal, dates from the 17th century. It comes from the other place on the planet most frequently affected by tsunamis: Japan. It was coined by fishermen who returned on a storm-free day to discover their port completely devastated by the waves. The most recent tsunami in Japan in 2011 caused the nuclear accident in Fukushima. Following a 9.1 magnitude earthquake, the devastating wave killed more than 18,000 people.
A tsunami has no meteorological cause. The primary cause of tsunamis are earthquakes and earthquakes at sea.
The vast majority of tsunamis are generated by the planet's tectonic activity. The Earth's crust is broken up into several large plates. Magma pushes them against one another a few millimeters to a few centimeters a year. The oceanic plates slide beneath the continental plates, forming subduction zones. Friction between the plates causes deformation of the continental plate, which accumulates a gigantic amount of energy. When the tension is released, it generates a huge undersea earthquake.
The earthquake displaces all the water at once. So if we are 4 kilometers deep, we have 4,000 meters of water that moves at the speed of an airliner. Very quickly, as we approach the coast, the speed is reduced, the wave gets bigger, and we find ourselves on the coast with waves of 20 to 30 meters, as we saw in 2011.
You cannot separate earthquake science and tsunami science. The longer the duration of the earthquake gives a very good indication of how strong the earthquake is. It's like a zipper. If you have a small earthquake, it's a short rupture area. And that means the duration is shorter. If it's a big earthquake like Sumatra, magnitude 9, or Japan, magnitude 9 plus events, then basically you have a very long zipper. That means the shaking will go on for several minutes.
Jesus Christ, look at that. Fucking hell. That wave is a good 15, 20 feet tall. Easy.
The longer and more intense the undersea earthquake, the more powerful the tsunami it generates. This is what happened during the terrible earthquake of December 26, 2004. In the Indian Ocean, a fault located 100 kilometers off the coast of the town of Banda Aceh on the island of Sumatra, Indonesia, broke on a line of 1,200 kilometers. The earthquake, with an exceptional magnitude of 9.1, lasted more than 5 minutes. 15 minutes later, 35-meter waves hit the coast. Continuing across the entire Indian Ocean, the tsunami claimed a total of 230,000 lives. A huge human disaster captured live for the first time by hundreds of video cameras. This disaster revealed the devastating power of tsunamis to the whole world. Before it, little was known about these deadly waves. For the scientific community, it is a wake-up call. It energized the science of tsunamis, which until then was in its infancy. Numerous international studies are launched. The research of Indonesian geologist Nazli Ismail will lead to a major revelation.
Here the tsunami reached 30 meters high up to the top of the hill over there. People rushed to the mountains, but very few survived.
Surveying the coast for traces of the tsunami, Nazli Ismail made an exceptional discovery 30 kilometers south of Banda Aceh.
After the 2004 tsunami, this cave was full of debris, full of pieces of wood. This cave has a very particular architecture. It is L-shaped and its entrance is parallel to the coast. So every time the water of a tsunami comes to submerge this cave, it is retained inside.
Nazli Ismail had a hunch. If this cave trapped the material carried by the 2004 tsunami, it could also hold the memory of past catastrophes. The cave had another particularity: bats. They have colonized it for millennia.
Each tsunami is covered by a layer of guano. You can see the layers of guano in black here.
Over the years, layers of guano, or bat droppings, deposited between each tsunami have become fossilized. They mark a clear boundary that delineates each event.
A layer of tsunami, then a layer of guano. A layer of tsunami and more guano. Then a tsunami, then more guano. Tsunami, then guano, and the 2004 tsunami.
With the help of researchers from Singapore's Earth Observatory, Nazli Ismail is able to date 12 deposits by carbon-14. They tell the story of tsunamis in this region over the last 10,000 years. The upper deposit corresponds to the 2004 tsunami. The next event is about 2,900 years earlier. Then, 4 tsunamis occurred 25 years apart, about 3,300 years ago. The oldest was about 7,500 years ago.
From the data obtained here, we have discovered that tsunamis are recurring irregularly. This is a lesson for both the government and the people. We have to be vigilant, to be constantly ready, because this disaster can happen at any time.
This exceptional discovery is a game changer. Now scientists know that where a tsunami has once struck, another can strike again.